And I'm Tharindu Fernando, and with this work, we are presenting a novel framework for task-specific visual saliency prediction with neural memory networks and conditional generative adversarial networks. So the motivation for this work is that we observe visual saliency patterns are subjected to number of factors, including what is the task at hand, human behavioral preferences, and domain knowledge. And also we observe that current state-of-the-art method underutilize this information and generate one single saliency pattern for all the tasks rather than modeling it with task-specific factors. For example, here we have the two tasks in Pascal VOCA dataset. And for the action recognition, the task is to say what is the subject doing in that given frame, and for the context recognition, the observer should figure out the background objects in the given scene. So rather than learning different networks for each and every task at hand, what we are interested in is learning it jointly and complement with the additional information. So here we have, on your right, we have the proposed framework. So we have conditional gang, which learns task-specific loss functions. And we incorporate a neural memory network in order to model the task-specific and also human behavioral patterns. The model should learn automatically to save and retrieve the additional information and incorporate that to the gang in order to give better predictions. If I give a brief overview of the proposed memory model, so we have the encoder on the bottom. So it encodes the generator encodes the given visual input, and that is used by the read LSTM function, which generate a vector in order to query the memory. And the initial memory output is passed through a multi-layer perceptron, and that is finally used by the write LSTM function, which updates the memory and takes the memory to the next state. So we evaluated the proposed method in Pascal VOCA and also MIT PD datasets. And as you can see, the proposed method is capable of outperforming the state-of-the-arts with a significant margin. And also we evaluated metrics such as normalized scan path saliency and cross-correlation. And in that scenario also, we were able to outperform with outperform the state of the arts. And here we have the task-specific activations for the two tasks in Pascal VOCA, which is action recognition and context recognition. The activations are taken from the second and the 8th convolution layers of our model. And as you can see, the task for action recognition is to figure out what subject in the frame is doing. So we have more yellow colors implying that there's more weight given to the subject, whereas for the context recognition task, it is to figure out the objects in the background, so more weight is given to the background. So with these, you can understand that the proposed method is jointly learning for the two tasks rather than learning, fine-tuning the model for different tasks. And so in order to conclude, what we introduce here is a method to combine task-specific and user-specific information to the generic GAN pipeline. And we were able to fully capture the context information, including task-specific and subject behavioral patterns. And this proposed method enables direct transferability among different tasks rather than fine-tuning individual networks for different tasks. And also with two public benchmarks, we demonstrated that we are capable of outperforming the state of the art. Thank you, and if you have any further queries, please visit my poster. Thank you.